Alright, so today we are going over properties of exponents. So before we can go over everything about exponents, we need to know what monomials are, okay? So right here in this first box, we have monomials. We have 2, 2x, 0, 5/3 y, 9a squared, b to the 5th, c to the 7th, the square root of 5, and so on and so forth. So what are some things that monomials can include? Numbers.
Fractions.
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 Decimals.
Or decimals.
No.
Variables.
Negatives.
Square root.
Variables.
Exponents.
Exponents.
Square root.
Fractions. Or
Zero.
Okay, so we have numbers, which would include fractions and decimals, so all types of numbers. Negatives, variables, exponents, square roots, and 0. Okay, now on down here we have 2 plus x. So here we've got, these are not monomials, so monomials can include operations. Cannot. So they cannot have operations. Right here, 9 divided by x. Why is this different than 5/3?
Because that's division.
It's dividing by a what?
Variables.
Okay, so cannot include dividing by variables.
Division by variables.
Again, this one includes an operation. That's why it is not a monomial. Square root of x. What makes that different than the square root of 5?
Because it's variables.
Okay, so can include square roots of variables. Okay, so we have lots of things that it can include, and then a few things that it cannot include. So dividing by variables, taking square roots, cubed roots, any type of roots of variables, radical variables, and operations. So with our practice, you guys are going to tell me whether or not it's a monomial. So 1, 17 minus c? No. Why? Because there's an operation. Or you can say because it's subtracting. 8f squared g. Yes. We can have, I don't know why I'm putting yes. Yes. Interesting. 3/4. Yes. The next one's what? No. No, we cannot divide by variables. 9 divided by x, 5 divided by t. No, because dividing by variable. Okay, be careful on this one. This is the one that gets most people right here, okay? All right, so we have some vocabulary. Some of it you guys should have already known. Some of it's, pretty much all of it you should have already known, okay? A constant. So it says a monomial that is a real number. A number that's not being multiplied by any variable. So guys, it's a number. So what are some examples of a constant?
1.
1, okay? It can include positive numbers. It can also include negative numbers. So it could be -1. Can it include 0?
Yeah.
Can it include decimals?
2.2.
3.2 is a real number. Okay? Negative? Yeah. Fractions. Give me a fraction.
1 and 2/5. 1 and 69.
Why are y'all giving me mixed numbers? Y'all know I hate mixed
I
numbers.
said 169. 8/4.
8/4. That can be simplified. Why would you give me that one?
169. Yeah, 1.5. 8/4 is
8/9. Okay, coefficients are numbers being multiplied by a variable. Again, please understand, this is being recorded. I can send this home to your parents and tell them the kind of jokes you're trying to make in my class right now.
I didn't try to make it.
And I know they are not going to be pleased. 2 boys in my room right now. Coefficients, a number being multiplied by a variable. So
2x.
2x. In 2x, what's the coefficient? The 2. Negative 2x, what's the coefficient?
-2.
Negative 2. The coefficient's simply the number in front of the variable. Okay, can it be a fraction?
Yeah.
So 1/2 y, anything like that. You want a decimal?
-0.25.
Negative 0.25. What variable you want to use?
L.
L?
W.
I'll go with W.
But the ramps.
Okay. And then powers is going to be a term with an exponent. So what did y'all come up with?
X squared.
Okay, x squared. Okay, did you just say 2x2? x2. That's not saying anything.
X cubed.
This is x2. You said x2, right?
X cubed.
X cubed. We can do x cubed.
X to the third.
X to the third power is x cubed. All right. So anything with an exponent, can it be, guys, can it be 5 to the third power?
Why not power?
Yeah.
What about 2?
It could be 2 to the 5th power. I'm so sorry.
What about 5 to the 4th power?
Remember, powers are exponents. Okay. Y'all are all over the place. All right. So this was our basics. We have to know our basics before we could go over to the next page and simplify monomials. Okay. So that's what we're doing. Our exponent rules or power rules are going to be simplifying monomials. So we're going to talk about today multiplying and dividing only. Okay. So first part is our example. So we have 5x squared y to the third all times 4xy to the 4th. Okay. And so the whole point of this was for you guys to figure out what the rule was. Because if you're like me, you don't want to have to do these steps every single time. If you know the rule, you can just apply the rule. Tyler? Otherwise, you would need to write it out, reorder, and then calculate. So when y'all simplified, we had 5 times 4. What did that give y'all? 20.
What else?
Okay. Then we had x cubed. Why cubed? Because there's 3 of them. So x cubed because there's 1, 2, 3.
Oh.
Mhm.
Oh, yeah.
And then you guys told me y to the 7th because there are 7 y's. Okay? And guys, remember, x squared is x times x, and then y cubed is y times y times y. That's how we write that out. It's something being multiplied by itself that many times. So what did you guys come up with? What did we have to do with our coefficients here? Multiply the coefficients. Remember, coefficients are the numbers out front of variables. So 5 times 4 gave us 20, so that we multiply. And then we did what with our exponents? Add the exponents of like terms. Okay, I'll go with that. So then we'd add the exponents of the like terms. So we had x squared and x. What is this x's exponent? Y'all follow me on that?
Yes.
This x right here. There's nothing written down. It's a 1. It's understood to be 1, just like if there's no coefficient, it's understood to be 1. So 2 plus 1 gives us 3. Y cubed, y to the 4th, 3 plus 4 is 7. Okay, so that's our shortcut, so we don't have to write all of this out every time, because I know y'all are not going to want to do that. Okay, and then our rule down here, the bases always have to stay the same. So if we have a to the m times a to the n, they are the same, they're going to stay the same, so the base is still a. The base means the bottom number. And then what do we do with the exponents? Add them, right? So m plus n. Some of y'all were trying to tell me mn. If I wrote mn, what would be happening? That would be multiplication. That's not the same thing as addition. Very good. Okay. Did y'all have any questions on these? I saw lots of good answers. Y'all were doing really well on this. Okay. Dividing. Y'all had a little bit more of a struggle with dividing. So again, they expanded it. So 18 x to the 4th y cubed divided by 6xy squared. So x to the 4th became x, and x. Y cubed was 3 y's multiplying, and then y squared is 2 y's. Okay? So you guys were okay. 18 divided by 6 gave y'all 3. So y'all did well with that. And then we kind of got stuck right here. Okay? We have an x on top and x on bottom. X divided by an x gives us
3.
X divided by an x gives us
1. 1.
1. Okay, just like 4 divided by 4 would be 1, x divided by x is 1. So when we have an x on top and an x on bottom, they cancel out. Some of y'all were writing cancel out. However, how many x's are left on top? 3. So that would be x cubed. Okay, now how many y's can we cancel out? How many pairs do we have? We have 2 here, and then we have 2 here. So how many are we left with? 1. Y to the first power. If it's y to the first power, do I need to write a 1? No, we just have to write that y there. Okay, so since there's 1 on top, 1 on bottom, those go away. 1 on top, 1 on bottom, those go away because it's 1. So our shortcut, what did we do with our coefficients? Divide. Guys, it's dividing, so we're going to divide our coefficients. Okay, now we do not cancel out the exponents. What do we do with the exponents? We subtract. So we are subtracting our exponents. So 18 divided by 6 gives us 3. 4 minus 1 is 3. 3 minus 2 is 1. We're simply subtracting our exponents. And then for our rule, again, the bases have to be the same. A to the m divided by a to the n. They are both a. It stays exactly as is. And what do I do with this m and n? Subtract. And guys, it's always going to be the top exponent minus the bottom exponent. M minus n. Not m minus m. Right? M minus n. No. I give up. Okay? Alright, so let's do some sample problems because this is what your homework is going to be on tonight, those of you that have not started it yet. So right here, what operation is happening between these two monomials? Multiplication. How do we know? Yeah, parentheses, right beside parentheses is multiplication. What do we do with our coefficients? What multiply our coefficients? What are our coefficients? Good. So 2 times negative 4 gives us negative 8. Okay? Then we have an a. This a has what as an exponent? 1. I'm going to write that down so I don't forget it. So I have a here, and then I have a cubed here. What do I do with their exponents? Add them. Notice I'm only putting the a exponents together. Okay, they have to have the same base. So a to the first times a to the third gives us a to the fourth. 3 plus 1 is 4. Make sure your exponents look like exponents. Make sure exponents look like exponents.
Who are you talking to?
Somebody whose exponents were as big as the variable. This one's a little too big too, but you know. All right, then we have b. So b squared times b cubed. So what do I do with those exponents? 2 plus 3 is 5. Does C have any friends? No. So he's just going to be back here and he's still a loner. Okay? So instead of having to write everything out, regroup, and then combine, we simply multiply our coefficients and then add the exponents of our like terms. Okay, I'm going to go ahead and do number 3 because this one's also multiplication. 6 and 2. 6 times 2 is 12. X squared and an x gives us x what? Cubed. The problem is this x does not have an exponent written out, so a lot of times we forget it. So make sure you remember, if it does not have an exponent written down, it's 1. It's understood to be 1. 2 plus 1 is 3. Okay, and then y cubed and y to the 5th gives us y to the 8. And how did you get that? Added those exponents. 5 plus 3 is 8. Okay, so we've taken 2 separate monomials and rewritten it as a single monomial. Y'all good with that?
Yes.
Okay, now division, what do we do with those exponents? Subtract. So x to the 11th divided by x to the 5th. What's going to stay the same? X. 11 minus 5 is 6. So x to the 6th power. Always the top exponent minus the bottom exponent. Okay, 4 is a little trickier. We have 35a to the 5th, 7a, divided by 7a. So what do we do with these coefficients? Divide. 35 divided by 7 is 5. What is this exponent down here? 1. So a to the 5th divided by a to the 1st gives us a to the 1/4. 5 minus 1 is 4. How many of us got all of these right? Okay, y'all got any questions, or y'all okay so far?
I'm okay. I finished my homework. Number 3 on the other rules.
Okay, we'll go over that.
What happened?